congruent pieces that if you folded them, they would fold back together and make a perfect match. So what I mean by that, if I drew a line right through on this figure, right through here, and I would fold this point over to this point, everything would match up just perfectly, and we would have a perfect match, two congruent parts. So that would be considered line symmetry. So this one has one line so far of symmetry. Also, you could go from here to here. So this one would have two lines of symmetry. And then again, if I folded this over that way, that's going to match up perfectly. Now going diagonally, if I would cut through diagonally, since it's kind of a parallelogram type figure, and I would fold it over that diagonal line, things are not going to match up. So we're going to get to, this is an acute angle trying to match up with an obtuse angle. It's not going to work if I would go diagonally. So this one would have two lines of symmetry. So you're going to look for that line symmetry, and then this one would have two lines. And that also shows that it has line symmetry when you say that. So there's our first piece of information. Next is rotational symmetry. So rotational symmetry is anytime you can rotate the figure, and then as you're rotating it, it's going to match back up to what it was originally. Now the one little stipulation is if you have to rotate it all the way 360 total degrees, then it doesn't have rotational symmetry, because all you did is just rotate it around and it's right back to where it started. So that doesn't count. But if you can rotate it and then it matches up back to where it was, then you can call rotational symmetry. So here in this figure, I've got this acute angle right here. If I would rotate it all the way to here, it's going to match up again with that acute angle. And then if I do it again, if I rotate it again back to here, then it would be back to the original. So it would take two rotations to get back to its original position. But when I get this rotation to here, that acute angle would match up again with that acute angle. That's going to have that rotational symmetry. Now to find the angle of rotation, we have to think about, if you do full circles, how many degrees is that? That would be 360. And then how many times, as you rotate, how many times are you matching up with that original figure as you go around? You're going to match up 2 times. So that would mean that each of those rotations you're making is 180 degrees. Whoops, that's not 180 degrees. So this rotation right here was 180 degrees. And then this rotation up here was 180 degrees. So every time I rotate 180 degrees, it's going to get back to its original shape. And I just have this here. This is something from my lunch yesterday. So if we have just a regular square, so if I kind of follow this tab here, so this tab, as I rotate it, so there's 1 rotation, 2 rotations, 3 rotations, 4 rotations. It takes me 4 rotations to get it back to its original starting point. Well, this then would have 360 divided by 4. It's going to have a total of 90 degree rotation. So it takes 4 times to do that 360 degrees. That means that it's going to have every 90 degrees, it's going to be matched up. And I'm disregarding this tab, that doesn't count, but that would be 90 degree rotation. We can head to problem number 2. If we look at problem number 2, if I split this right down the middle, this trapezoid, that's going to give me 1 line. I can't do anything else. There's no other lines. And then as far as rotational symmetry goes, I would have to rotate this one a total of 360 degrees to get back to the original. So this one does not have rotational symmetry. So that one wouldn't work. Next, we go to this hexagon. And this hexagon, it's looking like everything is exactly the same sides. So I could fold it there, I could fold it there, I could fold it there. So far I have 3, but hold on, we can go corner to corner. Since it's a perfect hexagon like that, so we got 1, 2, 3 more. That's going to be a total of 6 lines of symmetry. So that one would have a total of 6 lines. And then I look at that hexagon as I start to rotate it. Well, how many times can I rotate it within that 360 degrees? And I would be able to rotate that 6 times. So if you kind of pick a point and you count, that's 1, 2, 3, 4, 5, 6. It takes me 6 times to get back to the original. So I would take 360 divided by 6. That's going to be 60 degree rotational symmetry. So that's how we can find that rotational symmetry and how we can find the line symmetry. The other type of symmetry that is introduced is called point. And point symmetry is any time you can rotate something 180 degrees and it's still it's got that symmetry. So just going back to example 1, since this one did have 180 degree symmetry, this one also has point symmetry. And since as I would rotate this around 60, 120, 180, I do have 180 degree rotation within that rotation. This one would also have point symmetry as well. So point is any time you have rotational symmetry that falls right into 180. So if you can rotate something 180 degrees at some point and it's going to be back to the original figure, that's going to be point symmetry as well. So those are just some of the main ideas, taking a look at section 9.4. So you have a couple more there to practice. Start looking at some figures we talked about in chapter 6. What type of symmetry do those have? So on and so forth. Yes, you can just write point. So point communicates, that's 180 degrees. So point means just 180 degree rotation. So correct. And on your quiz will be, it'll be kind of like a multiple choice, or actually more like a matching. And so you just pull point in. If it's got 180 degree rotation, you'll pull point in as part of your symmetry. So thank you for asking that. So yes, you can just write point and that'll count as that type of symmetry. All right. Well, that brings us to 8:30. So if you're ready to break off on your own, you can break off on your own. I will be here to assist you as needed. But have a great rest of your day. And if I don't see you tomorrow, have a great weekend. And we would see you again, A group on Wednesday and B group on Thursday. So again, have a great day. And I will be around to help out with any assistance that you need.